Hello students, welcome everyone. Welcome to your favorite channel Vedantu NCERT Solution, where you're getting detailed solution of each and every questions of your NCERT, and we will help you to solve all the questions easily so that you can score more in your examination. So let us try to solve question number 10 of exercise 1.2 in this session. Let us try to understand the question. Let us try to decode the question first, and let us try to check whether these functions are 1, 1 and on 2. Let A under the set. A is a domain and B is a codomain because here the function is from A to B, and A is defined as a set of real numbers excluding 3, and B is defined as a set of real numbers. B is defined under the set of real numbers excluding 1. So remember children, this is very important. A is set of real numbers excluding 3 and B is set of real numbers other than 1. So this function is related, that is domain is under the set A and codomain is under the set B, and we need to check whether the given function is 1, 1. Now see children, always when we're checking whether the given function is 1, 1, what we used to do in the previous questions, we used to check f of x1, when we equate f of x1 to f of x2, are we getting x1 is to x2, x1 is equal to x2, we used to check, correct? If x1 equal to x2, then we used to conclude that there are no two values in the domain for which the same value is in the codomain. Those two values what you're taking, x1 and x2, is nothing but the same, correct? Same logic we are following children. Yes, we will check whether f of x1 and f of x2, when it is equated, are we getting x1 equal to x2? If we are getting x1 equal to x2 here also, then we come to a conclusion that it is 1, 1. Now x1 minus 2 divided by x1 minus 3 in the denominator, and you can see children, in the function in the denominator we have x minus 3. That's why it's set of real numbers excluding 3, because when you substitute 3, that becomes infinity, correct? So here x2 minus 2 divided by x2 minus 3. Yes. Now if you're cross multiplying children, just observe, it becomes x1 x2, yes, minus 2x2 2x2 minus 3x1 plus 6, which is equal to again x1 x2 here, x1 x2 minus 2x1 minus 3 times x2 plus 6. See children, exact same terms either side of your is equal to symbol, that is your left hand side and right hand side, can be cancelled, x1 x2 and 6, and remaining is minus 2x2 minus 3x2. Minus 3x2, take it to the other side, it becomes x2, minus 3x1, take it to the other side, it becomes x1. So we are getting x1 equal to x2 here, right children? When we get x1 equal to x2, what do we conclude? We conclude that the given function is 1, 1. So we write f is a 1, 1 function. That means every value in the domain is linked to a unique value or the distinct value in the codomain. Now let us check whether this is onto. And what we used to do in onto children, when we are substituting x in terms of y and substituting in the function f of x, if we are getting f of y is equal to x, that implies it is onto. Let us check, is it true in this case? Now first we need to write the function in terms of y, right children? That is the first thing. So when we are writing this, just observe what happens here. X minus 2 will be written as xy minus 3y, right children? If you try to simplify, take this xy to the other side, it becomes x into 1 minus y. True children? Because you take xy to the other side, it becomes minus xy. So from x and xy, if you take one x common, it becomes 1 minus y, and on the other side we have 2 minus 3y. So just observe here, what can be written as x now children? X can be written as, yes, what can be written? X can be written as 1 minus y in the denominator, and what do you have in the numerator? 2 minus 3y, right children? You have 2 minus 3y in the numerator. So we get 2 minus 3y divided by 1 minus y in the denominator, and you can see here y codomain was defined in such a way that its set of real numbers not equal to 1, because when you substitute 1, this also goes to infinity, right children? Can you relate them now? Yes. So x, you got it as 2 minus 3y divided by 1 minus y. Now what you are supposed to do children? You are supposed to check whether f of 2 minus 3y by 1 minus y is giving you the value y. In that case, we will conclude it is onto, otherwise it's not onto, correct? Let us try to substitute here. In the place of x everywhere, you are writing in terms of y, right children? In the place of x everywhere in the given function, you're going to write it in terms of y. So if I'm writing this, what was a function? Tell me. A function was x minus 2 by x minus 3, correct? So it becomes x minus 2 by x minus 3. So in the place of x, what are you writing? You are writing 2 minus 3y by 1 minus y. So I will write here, it's x minus 2 in the numerator. So that would become x minus 2 times, in the place of x you're writing, right? X minus, sorry, so x minus, so in the place of x it is 2 minus 3y divided by 1 minus y minus 2 in the numerator. Denominator, what are you getting, children? Just observe, it's x minus 3 in the denominator. So in the place of x, what you're writing, it's 2 minus 3y divided by 1 minus y, x minus 3. Simplify this, children. When you simplify this, are we getting it as y? Just check. 2 minus 3y minus 2 plus 2y, y minus 1, it gets cancelled, so we are not writing that. So 2 minus 3y minus 3 plus 3y. Yes, children? Are we getting this? Yes. Which is equal to what, children? If you are trying to simplify here, what are you getting? Just observe this very, very carefully. After the step, you can see minus 2 plus 2 gets cancelled. Yes. And you can also see minus 3y plus 3y gets cancelled, and 2 minus 3 becomes minus 1 in the denominator. That's correct. And in the numerator, minus 3y plus 2y is going to give you get minus 1 in the denominator, and numerator you're going to get minus y, and this is going to give you value y. Yes or no, children? Observe this very carefully. Minus 3y plus 2y is minus y. 2 minus 3 is minus 1. So you're going to get y, and you got f of x is equal to y. What is the conclusion now? F is onto, correct? In that case, the function is 1, 1 as well as onto. So you can write f is 1, 1 and onto. Was it very simple and easy, children? Yes. So we have solved question number 10 of your exercise 1.2, and it is a bijective function. It is 1, 1 and onto. I hope you have understood this. If you have understood all these questions, and if the questions are getting easier, please like, share and subscribe and share it with your friends so that even they can solve all these questions and master all these questions. Thank you, students.